Okay, hello everyone. So we have already covered Lorentz force, we have already covered force on a charged particle in magnetic field. Now our next topic is motion of a charged particle in uniform magnetic field. So we will be learning basically three motions. The first motion I'll cover in this slide. Okay, so first we'll cover the basics. So we already know that force on a charge q moving with velocity v in magnetic field B is F equal to q v cross B. Now remember that when you cross product two vectors like v and b are, there's a cross product between v and b. So the result of a cross product is a vector only. So that vector is F. But remember that F will be perpendicular to V also and F will be perpendicular to B also. So if you cross product two vectors, then the resultant vector will be perpendicular to both these. So F is QV cross B. It means F is perpendicular to V also, F is perpendicular to B also. Now, if you remember in 11th class, the topic called circular motion. So when force is perpendicular to velocity, motion will be circular in nature. So what happens in a circular motion? In a circular motion, force is towards center, but velocity is tangential. So force and velocity are perpendicular to each other. So if force and velocity are perpendicular, the motion will be circular in nature. So you have to remember this thing. And if you remember, if a mass m is moving with velocity v in a circle of radius r, then the force that is required, the force that is required to continue this circular motion should be equal to mv square by r. This is also called as centripetal force, and the direction of this force is towards center. So the force required for a particle of mass m to move with velocity v in a circle of radius r is mv square by r. So for circular motion to exist, the resultant force should be towards center and its value should be mv square by r. And in case of magnetism, this force is provided by magnetic force. So the first case we'll cover is motion when V and B are perpendicular. So if V and B are perpendicular, then theta will be equal to pi by 2. So force due to magnetic field will be only QVB. And this force will be perpendicular to velocity. So this force will provide the resultant required centripetal force to move in circular motion. And the force required is mv square by r. So this force is being provided by this force. So QVB will be equal to mv square by r. So what we have done is, and what in magnetism is, the force that is being required to move a particle in circular motion is being given by magnetic force. So magnetic force will be equal to centripetal force. So if we'll equate both this equation, then V and V will cancel out. So radius will come out to be mv upon qb. Now if we'll see, the radius depends on mass of charge, velocity of charge, value of charge, and value of magnetic field. Now there are few variants of this formula. See, mass into velocity is linear momentum. So P is mv. So radius can also be written to be equal to P upon qb. Now if you remember that relation between linear momentum and kinetic energy is P equal to root 2 mk. So radius can also be written to be equal to root 2 mk by qb. Now when to use this formula is very important. Like if in question, suppose they are talking about linear momentum, then you have to use this formula. Suppose in question they are talking about kinetic energy, then you have to use this formula. Suppose in question they are talking about velocity, then you have to use this formula. And there's one more variant. Now see, if you accelerate a charge q with potential difference v, then work done will be potential difference into charge, and all the work done will be equal to change in kinetic energy. So kinetic energy can also be substituted to qv. So if they are talking about potential difference, then you have to use the third formula, that is r equal to root 2m qv upon qb. Here m is mass, q is charge. Here v is potential difference, not velocity. The v here is potential difference. B is magnetic field. Now on the basis of this thing, let's solve some numericals. So the first numerical is two charges Q and 2Q of same mass, see mass is same, are launched with same velocity. So I'm talking about velocity in magnetic field B. Find ratio of radius of their path. So R is mv upon qb. So R1 will be m1 v1 upon q1 v1. R2 will be equal to m2 v2 upon q2 v2. So we'll divide both this equation. See, mass is same, so it will cancel out. Magnetic field is same, so it will cancel out. Velocity will be same, so it will cancel out. So ratio is q2 by q1, that is 2 upon 1. So this is how you have to use these formulas to find ratios. Okay, we'll solve one more numerical here. So we have two charges q and 2q of same mass. See, mass is same, are launched with same potential difference. So V is also same. V is potential difference in magnetic field B. The value of magnetic field is given to be B, and it is also same. Find radius or ratio of their path C. R is root 2 mqv divided by qb. Now remember one thing. When we talk about velocity, the formula that you have to use is mv by qb. When we talk about momentum, P by QB. When we talk about kinetic energy, root 2mk by QB. And when we talk about potential difference, then root of 2mqv divided by QB. Now, for the first charge, we'll write R1 to be root 2 m1 q1 v1 upon q1 b1. And for second mass, we'll write R2 will be equal to root 2 m2 q2 v2 divided by q2 v2. If you divide both the radius, then 2 will cut out. They are with same mass, so mass will cut out. Potential difference is same, so V and V will cut out. Magnetic field is same, so B and B will also be cut out. Now if you'll see, root Q1 by Q1 will be root Q1 and Q2 by root Q2 will be root Q2. So the final answer will be root 2 by 1. So in this lecture, what we have covered is, if a charged particle Q, suppose if it is placed in a magnetic field perpendicular to the magnetic field and it is launched with some velocity V, then the particle will be in circular motion and the radius will be given by mv by qb, the most basic formula. Now the thing you have to remember here is that v and b are perpendicular, then the path is circular in nature. Because if v and b are not perpendicular, then what will happen, we are going to cover in upcoming lectures. So you have to remember the formula, you have to remember the concept. The most important concept is that if force is perpendicular to velocity, the motion will be circular in nature. Okay, if you have any doubt, you can ask me, and also you have to submit a quiz that I'll send by email. So you have to submit quiz of this topic. Okay, if you have any doubt, you can WhatsApp me.